Hello everyone, my name is Jamil and welcome to another video. So today we have another lead code on the menu. It's number 1572, matrix diagonal sum. I have a little bit of a different approach for this one here today because I'm really not super comfortable with the question, so I have it open on the side and I'm going to be going through a quick explanation with you to try and tell you how I came up with the solution. It's going to require a little bit of illustration and I am not the best illustrator out there, so I hope you can follow along. But without further ado, let's jump straight into the question and see what it is asking of us. So we are given a square matrix denoted by the variable mat, and we need to return the sum of the matrix diagonals, okay? So only include the sum of all the elements on the primary diagonal and the element on the secondary diagonal that are not part of the primary diagonal, okay? And that is an important bit of information. So let's take a look at our first example. Okay. Example number 1 tells us we have a 3 by 3 matrix. So what does that mean? We have 3 rows and 3 columns. So a row will go from left to right horizontally, and a column will go top down vertically. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Fairly simple. We have a secondary diagonal and a primary diagonal. And so what we need to do is we need to add 1, 5, and 9, and then 3 and 7. Okay. And so you will notice that mat 1 and 1 gives us back the number 5, because row 1, column 1 will give us the number 5. So example number 2, it doesn't give us an illustration, but it's 1 across the board, and the output is 8, because the diagonal and the secondary diagonal, the primary diagonal and the secondary diagonal differ in this case. And let me give you a little bit of an example here to show you better what I am trying to say. So I'm going to pull up my handy dandy paint that I put together right before this video. I hope it's very clear. So we have a 4 by 4 matrix. So it goes 1, 2, 3, 4 all the way up to 16, right? Because this is JavaScript and we are dealing with arrays, right? This matrix is represented by an array, essentially. So if you take a look at here at input mat, you'll see that we have nested arrays, right? 1, 2, and 3, 4, 5, and 6, 7, 8, and 9. It's going to be the first row is 1, 2, and 3, and that is a nested array within the array mat, right? 4, 5, and 6 is another nested array within the array mat, so on and so forth. Okay, so what you can say is, if I take this orange color right here, I can denote this by saying this is a row, comma, this is a row, comma, and then this is a row, or an array, sorry, right? And the same thing here, array row 1, 2, 3, and 4, or index 1, 2, 3, and 4. But since arrays, are 0 indexed, they start at index number 0. Okay? And the reason why I have this set up for you like this, I don't like this example number 2 here, is because it doesn't show you really what is happening, right? We need to add on this new array that I have here on the side, we need to add, 1, 6, 11, 16, 4, 7, 10, and 13. And that's how we would end up coming up with our solution. And none of these things overlap. So you would have to determine where these values land. So if we visualize it this way, we can say that the number 1, and I'm just going to write the start in black, right? If you say mat, and it is 0 and 0, that is equal to the number 1. That is this index right here. Okay? Mat 1 and 1 gives us the number 6, right? 2 and 2, 2 and 2 will give us the number 11, right? I'm just going to put these like this just for, sorry about this, but I don't have a better way of illustrating this, so I'm just writing this out with my mouse. But basically what you're seeing here is you have 16 and 16. So this is our primary, and I'm just going to write it in red, primary diagonal, okay? Primary diagonal, okay? Our secondary is what? Okay. Our secondary is mat 0, and 4, which is what? It is the number 4. Oh, sorry. Not 4, but 3 is equal to the number 4, right? You keep doing this, and you get mat 1, 2, right? You get mat 2, 1, and then mat 3 and 0. And the reason why I wrote it out like this is because I want you to recognize one thing. The important bit of information here that we have is that we have a matrix length, and we know that our matrix length is 4. So mat dot length is equal to 4. Okay, so if we know mat dot length is equal to 4, we know our number will never and it's 0 indexed, our number will never be greater than 3, right? If for this one mat dot length is 2, right? I'm just going to write m dot l here is equal to 2 is equal to 3, sorry, then you are not going to receive, an index. So it'll be mat 0 and 2 for our secondary matrix, right? This is our secondary matrix in this 3 by 3. Now, a matrix with an odd length is treated differently than a matrix with an even length. And this is also something that I need you to understand, okay? Because the matrix with an odd length will have overlapping numbers. You will notice here that our intersection is the number 5, right? And matrix with an even length does not have an intersection, right? We go 4, 7, 10, 13, and 1, 6, 11, and 16. None of these numbers overlap. But how do we end up finding the formula so that we can build our secondary array or our secondary diagonal? You can say that 0 plus 3 in this case is, the sum is 4, right? So you have your first index, right? And you have your last index, and the difference should be 4. So if you have your variables I and j, or I and length, right? So if you replace your number here, let me see, what color should I use here? If this is I, okay, and this is mat, I'm just going to bring this down here. This is mat dot length minus I, right? Because we always want to be within the number 4. This is important. This is our most important. We always want to remain within this mat dot length, right? We always want to remain within mat dot length. So if we see here, if 3 minus 0, right, or like it's 3, 0, it's 4, like if we go back up to a 1 indexed matrix, you'll see 1 and 4, right? 1 and 4. 1 and 4, 1 and 4, 1 and 4. Essentially what is happening here, if you were to index this properly, since we know mat.length is essentially like it stops at the number 3, right? We can say it's mat.length minus 1. Oh, this should be minus 1 minus I. Okay? Mat.length minus 1 gives me the number 3, which is the maximum, and then minus I will give me the index or the value in the array. And that's how we end up finding out what these numbers truly are going to be. So this is going to be 7, right? This is going to be 10. Let me just fix that. 10. And this is going to be 13. Okay? So with that in mind, let's start building this out, because what we are going to need to do is we are going to build out a primary diagonal, we are going to build out a secondary diagonal, and then we are going to add those numbers so that we can get what the question is asking of us, which back here, if we take a look and see, is to return the sum of the matrix diagonals. So we take the total of these numbers, the total of these numbers, add them together. That is the answer. Okay? So we just have to figure out what those numbers are. And I hope that with this, you sort of understand what is happening here. So let's start by building our function here today. We'll start with our regular processes here, and what I will do is first we were going to understand what is being passed in. Okay, so we are passed a matrix. Okay, so what does that mean? A matrix is an array of nested arrays. Each nested array will represent a row in the matrix. Okay, so you're gonna have a row and a column that you're gonna have to take into account, which is basically what this number with two square brackets following it are. So this telling us here is that we have a nested array of numbers. The nested arrays will exclusively contain numbers, so we don't have to take into account any letters or special characters. Perfect. So with that being said, what are we returning? We should return the total of the sum of a primary and a secondary diagonal in the matrix without having any overlapping numbers. Sounds simple enough? Just like I showed you earlier on our picture, let's try and get that done. So we're going to start off with, first, we need to come up with a variable to hold our sum. Okay, and this is what we're going to be returning. So let's say call it sum for simplicity, and it's going to be a number, and I'm going to start it off with 0. But then I'm going to need to, as I mentioned earlier here, you know, mat.length, we're going to be using it as a reference to build out our secondary matrix. Okay, we are using this number here to figure out, you know, where are we on our secondary diagonal, because each time we build a row, we need to subtract the, we go down a row, we need to subtract the row number so that we can figure out the index that we are looking for. Okay, we're going diagonally. So let's just say matrix length, which is also a number, equal to mat.length and -1. Okay, so why that? Well, because as we mentioned before, you know we have 4 and 4 for our matrix length and like height, but since we have 0 indexed arrays in JavaScript, instead of mat.length being 4, we need it to be 3. So 3 minus 0 will give us the number that we are looking for. 2 minus 1 will give us the number that we are looking for. And the same thing, 1 minus 2 will give us the number that we are looking for, but in the reverse, right? So, and this is basically a variable, Control Z, a variable to hold the length of the matrix and to use as a reference point to find our secondary diagonal values. Okay, so now that we have our variables out of the way, let's start iterating over the matrix, okay? And we're going to use a for loop. Sorry about this. It's also a number. And we are going to go for I is less than mat.length and then I++. Okay, so we're going to go for the entirety of the length, but I am not doing -1 here because it's just a less than operator. Perfect. So we can do two things. Build your primary diagonal. For the sake of simplicity, I'm going to say this. Let primary number equal to 0. Let secondary number equal to 0. Okay? And we're going to start building our primary. So it's going to be sum is equal to sum. Oh, primary is equal to primary plus mat I. So why am I doing that? Right? Back here, we noticed I, right? So 0, 0, 1, 1, 2, 2, 0, 0, 1, 1, 2, 2, 3, 3. You'll notice that I and I are here and here, right? I and I. These are repeating numbers. So this is our primary. Okay? And now, build your secondary diagonal. And secondary is going to be an conditional because we need to make sure that the condition comes in from this. All the elements of the secondary diagonal that are not a part of the original diagonal. Okay, so we need to make sure that we fulfill that condition, and the way that we do that, we are going to be using a conditional, essentially. If I, right, does not equal, so it's going to be matrix length minus I, right? Then what are we going to do? Secondary is equal to secondary plus, oh, no, we're just going to add the value. So we're going to do plus equals, yes, equals secondary plus matrix I, and then matrix length minus I. Okay? And then when we're done here, sum the primary and secondary diagonals. And you can say primary, so its sum is equal to primary plus secondary, and return the total. And we can say return sum. And I believe, since I've been cheating with this a little bit, that this is the proper solution. Is it the most optimal solution? I'm going to say no, because you can do a lot of these things in one step. But for the sake of simplicity and clarity, I want you to see which are the primary and which are the secondary numbers. This is very, like, clarity is important here so that you sort of understand what is happening. So, look at this. Primary is 1, secondary is 3. 1 and 3, all done in the same iteration of the loop. The next one. Primary is 6, secondary is 3. Oh, let me, okay. The reason why this is doing it is because it's 1 plus 5, which gives me 6. But then take a look at this. 3 doesn't change because 5 was already counted the first time around. We don't want to double count it. Then the next time, we have primary is 15, which is 6 plus 9. And then secondary is 10, which is 3 plus 10. So we know our code works. Case number 2, we have 1, 1, 1, and 1. So 1, 2, 3, and 4, 1, 2, 3, and 4, and our output is 8. And then if we have a single matrix, then it's just primary is 5 and secondary is 0. Cool. So let me just clean up the code here a bit. I am just going to, I'll do this. And I'm going to upload this specific solution to my GitHub, and then I will also update with the shorter solution so that those who want to see how you can just clear up some of this clutter here and then figure out, like, what a solution should look like in an interview. This is what the solution should look like in the interview, honestly. Like, you should try and waste as much time as you can so that you're as clear as you are, and then if you get stuck anywhere, they can help you out. But let's submit this. And perfect. There we go. Again, I really do not care too much about the runtime and the memory. I just want to know that I want the interviewers to know that I can present them with a solution. And then if they ask me to refactor it, I can go back and refactor it. So if you learned something here today, please make sure to like the video. I would really appreciate it. I will try to save this drawing that I put on the side so that people can also reference it, so that they know what I am doing, so that I can also have that readily available for them. If you like this video, please make sure to like the video. If you learned something, please leave it in the comments. Tell me what you learned. If you liked what you learned here today, subscribe to the channel, share it with your friends, and let me know. Once again, my name is Jamil. Thank you so much for joining me here today, and I'll see you next video.